Hi everybody, and welcome to today's webinar on handling ground types and materials in RoadEng. I wanted to start just by introducing myself as well as my colleague, kind of the webinars team here at Softry. So I'm Erin. I'm going to be the host for today's webinar, and with me is our training manager, Matthew Dickey. And he's going to be spending a lot of time today explaining, I'd say, one of the most underused aspects of RoadEng, which is really all about how ground types are integrated into your model and used for reporting. So let's get started. Today our agenda really is all about ground types. So we're going to start by talking about why ground types matter and why you should be using them inside of your RoadEng location projects. From there, we're going to talk about how we define ground types and materials. We're going to talk a bit about some of the geotechnical properties that ground types and materials have, including probably one of the most confusing parts, the expansion and shrinkage, or the swell and shrinkage factors, as well as the different slope properties for cut and fill that you can attach to a ground type. We're also going to talk a little bit about stripping, the idea of, or the concept, I should say, of material quality, leveraging borrow and waste sites, and finally looking at and implementing subsurfaces. That's sort of our agenda for today. Really, if I kind of leave you with one thing, leveraging ground types adds a huge amount of realism to your project and makes it much more closer to reality when it comes to your cut and fills. And with that, I'm going to pass it over to Matt. We're going to be doing a whole bunch of back and forth with PowerPoints and in software stuff today, so please do have a moment of patience as we do flip the screen back and forth about 5 or 6 times. But with that, Matt, over to you.
Cool. Well, thanks once again, Erin, for the intro. And yeah, we'll jump right into things here. So the first thing probably that we should talk about is why even consider this stuff to start with. So just we'll take a look at two different designs side by side. And at a glance, they may not appear to be very different. And that's largely because they are the same alignment. So same horizontal alignment, same vertical alignment. The only differences here are the what's assigned for kind of ground type information and kind of those related items that we'll talk to as we go through this webinar. So just at a glance at this 3D view, we can see that the design on the right has much gentler fill slopes and laid back cut slopes. So right there, if we kind of want to consider how that's going to affect things from a boots on the ground perspective, well, if we were laying out those slope stakes, we're going to be off a little ways from what should be there depending on the material we have assigned. Now this plays a bigger role when we start getting into the nitty-gritty. So it's one of those things where just a specific station, it might not seem like it makes much of a difference, but when you do that over your entire road, it certainly adds up. So these different materials that we have applied have different expansion and compaction factors and other geotechnical properties. And not applying those can lead to inappropriate slopes, inappropriate materials being used, and substantial volume differences, and yeah, you're not accounting for how you're actually interacting with the surrounding terrain. So with these two examples we have, first difference worth pointing out is, well, we've got stripping applied in one and not the other. So on that default ground material only, we're assuming that we can use all that material to use it in fill sections. But in reality, we, in this case, we don't want to. We don't want to include those organics in our fill, so it's going to get stripped out of there and disposed of. So we've got a difference in the stripping volume that we're accounting for of almost 12,000 cubic meters, so not a trivial amount. Then we have the cuts and fill slopes that are different, so this is going to compound on top of that. and our clearing area is different as a result. So we're increasing our cleared area by almost a hectare, so 10,000 square meters. But that also affects our volumes too, because we're laying back those cuts. We're cutting more material to do that. And well, at a glance, it looks like we're only cutting 1,000 more cubic meters in that subgrade cut. But keep in mind too that we're stripping out 12,000 cubic meters of that beforehand. So our total cut has gone up a lot. Now our fill goes from being 22,000 cubic meters to almost 30,000 cubic meters. So that is, it can be a big deal. We've got a deficit now. We went from having a surplus of 250 cubic meters to a deficit of 6,408 cubic meters. So that is a nuisance in and of itself. We need to deal with that, but we also have to haul that material in. So you can see these little details when put all together aren't little details anymore. And this example that we're looking at was a really benign example. If we scale this up to a road on steep terrain, it is much more pronounced, the difference. So here I've got a cross section where we're going along at the default settings. And if that's appropriate, great. If we'd be better off with a cut slope here of 1:1 and a fill slope of 1.5:1, that is an enormous amount of work that we haven't accounted for. It might be that the road has to go in another spot. It might be that if there's another spot, the project's no longer feasible. Or we have to really change our methodology for building through this section if it warrants it. So that's the why. Now, where these geotechnical properties are stored in the software, the vast majority of them get accounted for as ground types or related parameters. Now, our ground types table, which we can see in the slide, is kind of a library where we can add our own materials in there and give our materials our own names and our own geotechnical properties. So each ground type is just a holder of common conditions in that section. So if we have, in this case, OB applied, well, we're saying in this section we can cut it up to 400%, fill it at 1:1, and our cut and fill expansion factors are 1:1. So those parameters appear there. If we look at the cost tab, we've got other parameters. So we've got a quality factor, and we've got our handling costs, so unit costs to actually excavate or place, shape, and compact that material, and our movement costs. Now, I mentioned this is just a library that stores these different materials that we have to pull from. We can assign those materials in the assign by range side of the software. So similar if you're assigning something like templates, we can use the assign by range to assign things like subhorizons, fill types, site prep, and pits. So I'm not going to jump right into the software and focus on how applying all these different things works. I'm going to do my best to kind of break these out into those individual parameters and considerations and talk about how they affect things before we tie it all together. So the first item that we're going to tackle here is expansion and shrinkage. So that may be referred to as other things. So expansion and shrinkage, maybe your cut and fill factors, maybe shrink and swell, expansion, compaction, etc. Now, all these terminologies are meant to say, well, how does our fill volume relate to the amount of cut that we have to produce to generate it? So if you cut your material out of the bank, so we'll refer to this as our bank units, or in situ material, it's probably going to be stockpiled temporarily or thrown in a truck, in which case it would be loose. And then when it gets to actually being used as fill in either our road, prism, or other earthworks project, that'll be referred to as final or placed. Now these bank or final volumes, they're probably a little different from one another. So let's kind of apply some numbers to these here. So if we want to work in bank cubic meters, our cut factor is going to be set at 1. So we want to relate everything back to that cut factor of 1. Now, if we were to dig, say, a 10 cubic meter hole, well, it's going to be stockpiled temporarily, and then when we take that material and turn it into the road, in this case, we're going to assume that it has swelled. So here I've got a fill factor of 0.8. So what we're referring to there is that if we took that loose material that we've pulled out of that hole, and instead of turning it into a road, we've decided to let's fill in that hole, and we'll apply the same construction methodology and compaction effort that we would if it was a road to put it back into that hole. Well, if we filled up that hole and we got to a point where the hole was filled full, but we could only fit 80% of that fill material in there, so we still had another 20% left over, that 80% is that where that fill factor comes from, so 0.8. So a fill factor of less than 1 means your material is getting bigger or expanding from its in situ state. Now, that doesn't always happen. It could be that you dig that same hole and you discover that, oh, my fill actually, once it's placed, compacted and whatnot, it takes up more or less space than what was originally in the ground. For that, our fill factor is going to be a value that's greater than 1. So here, if we relate that back to putting that material back in the hole, well, as we're filling in that hole, we get to the, we run out of material before we get to the top of the hole that we've dug, and we realize, well, we could fit 20% more material in there. So that's where that fill factor of 1.2 comes from. So how does that affect our design? Again, really easy to brush over that and say, well, it's just a detail. But it does have an impact. It impacts how we design. It impacts how we report things. So here I've got a design, and I'm going to use the same one over and over again. And so backing up, I mentioned that we've got our ground types table. And whoops, of course I hit the wrong button right off the bat. We can go to assign by range, and we can see in our sub-horizons, I've just got the default assigned, so star, star. I haven't actually split this out. So that default material is being called out as overburden. And right now, before I make any changes here, we'll just take note that we've got a mass haul surplus of 262 cubic meters. And actually, I should move this over so it's actually legible. And we've got our cuts and fills being reported accordingly here. Now, if I were to change this to say, well, instead of having a fill factor of 1:1, let's assume that this material is going to swell. We can see, well, our surplus has changed. We've got a 2,000 cubic meter surplus now. Our cuts and fills change because these are factored volumes that we're producing. And, well, that's great to know, but it would be great to know while we were designing here so we could actually lift our road where appropriate so we don't have this surplus that we're creating for absolutely no reason and costing us more money. Now, alternatively, if we had have applied that fill factor of 1.2, it's going to be the same but opposite results. We're going to see that we have actually more of a deficit than what we've accounted for. And we would have wanted to drop the road into cut in some locations, but we're also going to just want to make sure that we have some idea of what's going on when we're actually reporting those volumes for costing. So I'm going to just change this back so we can, rather than looking at everything compounding as we add things to it, let's change that back to the way it was, and we'll look at our next topic. So I'll switch this back to Aaron. All right, so the next topic, and probably the most important topic for those of you that are dealing with roads on steep terrain, is your cuts and fill slopes. So this stuff is pretty straightforward. It's easy to see. The premise here is, depending on what we're going through, it may dictate how steep we can cut it or how steep we can fill with it. So to start, I'm not going to include different layers, but we will just look at how changing our cut slope and fill slope angles affects things. So same example. We've got the default material applied here. So we can see that. Just look at it in our cross section. So if we zoom out, we can see there's no other layers here. If we come in here, and if we only change our cuts and fill slopes, it has an impact similar to how our expansion and compaction factors had an impact. So I'm going to change this, change this to 1.5 to 1 and 1.5 to 1. We'll hit OK. We'll hit OK. And we'll see that our fills get laid out and our cuts get laid back as well. And that impacts how much dirt we're dealing with. And again, we end up creating this surplus that we weren't accounting for. So we're cutting more material than we need to. That's going to influence how much effort's required to build this. And we'll show it in another example, but you can have different horizons and whatnot for what we're dealing with. Now, before I go on to the next thing, I will just kind of add as a footnote that the reason this is influencing my cut slopes, or is allowed to influence my cut slopes, is the slopes parameter that I have assigned here. So right now my slopes and my templates are set to auto, so that's pulling in whatever cut slope or fill slope angle is assigned to my ground types. If I had set this at, say, 1 to 1, that's fixed. So it's no longer looking at the ground types I have assigned along the length of my road. All right. All right, and next we have our overburden removal. So for that, briefly explain that we probably don't want to include all of the material on the ground in our road prism as fill. So there's our topo surface, which represents the top of ground, but then there's usually a layer of undesirable materials. So in this case, in that image to the left, we've got a layer with a bunch of organics in it, roots in it, etc. And we probably don't want that in our fill. So we can assign site prep parameters for that. And that material is tracked as stripping in our volumes, and it won't be included in our fills or our mass haul. So let's, again, take a peek at that same example that we have on the go. And all right, so here's same example, and I just hit undo there, so we've got everything balancing, so it's easy to see, or close to balancing. It's easy to see the impact we're having as we change these things. So if I go into assign by range, this is one of those items that I don't necessarily have to relate it back to the ground types. We could add a an organic soil layer if we like, but we don't have to. We can just assign a overburden removal. So we'll go assign by range, site prep. And here I'm going to assume I want to remove 0.2 of a meter. And if I just left this as is, so my outside offset being based off centerline with 0 project units, well, it wouldn't do anything. If I wanted to, say, have the site prep based off of my road footprint, I'd set these as being slope stake base. I may even want to add in a little offset just for a little extra wiggle room. I'll click Add Edit so it gets updated here. And we'll hit OK. And we'll see, well, an impact in our volumes, an impact in our mass haul, and an impact in our cross-section. So there's our stripping. Now, just what we have applied. So my slope stakes, I've gone out to the edge of my slope stakes, and then I've gone an additional 0.3, and I'm removing 0.2 of material depth there. So we've reduced our cut volume, but we've increased our fill volume, or sorry, we've increased our stripping volume, so that material isn't going back into the fill, it's being disposed of. So that's being tracked there. Now, how does this affect our design? Well, now we've taken that surplus that was at 200 and some cubic meters, and now we've got a deficit of 4,500 cubic meters. So again, it's not a trivial change, and it is worth accounting for. And I'll just hit undo, and we'll jump back into our next. All right, so material quality requirements. And this is kind of where things may start to get a little complicated, and the premise is easy. It's just kind of like expansion and compaction factors, where the only reason it's complicated is it's a little harder to see. So I am going to leverage some of the graphics in the software to show it here in a moment. So it may be that as you're building your road, you decide that, well, rather than just using any old material for fill, it may be that I need a specific material for a specific section. Or it may be that I need at least maybe not a specific material, but maybe just a material that is relatively good. So for that, we can apply quality parameters to the materials that we expect to encounter. So Q1 being the worst, Q4 being the best. And we can use that when we assign things like fill. Now here, this is the assign by range dialog. If we have hard pan selected as a Q2, and we assign that for a specific station range, well, if we had that replaceable quality base checkbox turned off, it would make sure that we only assigned hard pan. Now, if we have that replaceable quality base on there, it ensures that anything Q2 or better gets used as fill material in that section. And we can use those quality parameters for other things in assigning what material can go to different waste sites, etc. So once again, we'll jump back into the software. And this is going to be the same example, but I'm going to switch the screen layout that I'm using. So same example, we've got a bit more going on here. I'm just going to take a moment to assign some subsurface, or sorry, not subsurface layers, but assign ground types along the length of my road. And the reason I'm doing that here is just it's easier to consider what's going on if we've got a little bit of variety. So I mentioned we can assign our materials and assign by range. I won't worry about everything. I just want to worry about my subhorizons here to start. And I'm going to tell it, well, let's assign my material HP from ... to station 160. From station 160 onward, I'm going to just say that it's solid rock to 685. And I could open this up and add that in one by one. Now in this case, I'm not going to because it's easy and I know what my codes are. So then we go from 685 to 1125. I'm going to say that we've got hard pan again. And then from 1125 to 1195, I've got gravel. And from 1195 on, I'm going to say there's hard pan. And I'm going to let it do its thing there before I zoom in and talk about assigning a specific quality requirement for a specific range. So in this example, I'm going to assume that through this fill section here, I'm at the edge of my tin here, so I'll zoom in so we don't have to worry about my sloppiness. If I want to ensure that this prism is made out of, well, let's say it's a granular material, I can. So I can go up into assign by range, and I could say, well, let's assign our fill types for the subgrade through that section. And I could say, well, let's go from 1435 to 1510. And, well, I want it to be granular, so let's assign gravel. Now in this case, I don't really care if it's gravel or if it's solid rock or if it's fractured rock. So my gravel is Q3. Those other materials are Q4. So if I just leave that as Q3, it's going to be replaceable. So Q3, it could be gravel, it could be any of those other materials without having to actually specify. So I'll click Add Edit. And we'll hit OK, and we'll hit OK. And this is kind of one of those things where just by doing that, there's not going to be a lot going on. So our focus here is on ground types and materials, but it's really difficult to talk about that stuff without having some appreciation for material movement. So why do we want to consider this? Well, we want to actually know where that material is coming from. So the mass haul diagram right now isn't showing us that, just because it's getting into that level of detail that it doesn't do a good job of accounting for. So let's go into our profile options. And let's look at our opti haul graph instead here. And it says out of date recost, so I'm going to do that. And what the software is doing here is it's actually figuring out where out of all those materials that we're dealing with along the length of our road, where can we pull that from? So here, if we pull this up, we see we've got some material going ahead and some material going back. If we hover over these things, we can see that we've got those different material types accounted for. Now this is a nice stepping stone into our next topic. Now before we go into the slideshow for that, I'm just going to expand this and we can see that we get this warning that we've got an underflow. So it's telling me that I'm 285 cubic meters shy on having that material that's Q3 or better, but at the same time, I've got an overflow. So I've also am cutting a surplus of material of stuff that I can't use there, and stuff that I can't use along the rest of my road. So this is a surplus of 2,700 cubic meters. So let's have a peek at boro wastes and side casts. So the first item that we should probably touch upon is boro pits. So boro pits are assigned in the software and used to represent where you're hauling in material from something other than your road. Uh, most commonly a boro source or a gravel pit, quarry, etc. So with these, we can assign what material we can source from that location. And if you have the flexibility to extract more than one material from that site, you can add in multiple boro pits at the same location. Now, spoil sites are the same but opposite. So here it's if you have a surplus of material and you need to haul that material away to dispose of it at a spoil site, we can add a waste pit. And we can also apply some quality parameters there too, where if we need a specific requirement for that, we can assign it. And then really similar to waste pits is this idea of side casting. So what I'm referring to here is it costs money to actually haul material to a spoil site, but if we can just dispose of it next to our road and not worry about it, well, we can account for that in the software as well. So sidecast, you won't assign, well, this sidecast material needs to be this of this quality. It's going to be based entirely on what it isn't being used to meet your quality requirements elsewhere on your road and material requirements elsewhere on the road. And I should mention for that waste pit as well, you don't have to assign a material. It can just be Q1, so any material or better. So let's continue along in that same example that I had. So I'll just So picking up where we left off, we have this warning that we've got a deficit. So let's say that we can add a boro source to account for that deficit. So right now, this warning is telling us that it's undefined, and with that, it's adding in an artificial pit. So it needs to balance it, and it's showing up as this little red icon here. Well, if we can actually use our gravel source, well, we probably should. So I'm going to say at station 1140, we can assign a pit. We'll come in here, we'll click add 1140. So this is going to be a boro pit. I want it to be, gravel. So we can click that. We can leave it as a variable volume smart pit. I've got a capacity set at infinite. So this is going to do its thing. And we can see, well, we've got this little boro pit icon showing up here. So we're borrowing 350 cubes of gravel to address that. Now with this, we still have a warning that we've got the overflow. So all that hard pan that we're digging through isn't suitable for what we're working with. So we can tell the software where are we allowed to put that. So same but opposite. I'm going to add a pit. I'm going to say, well, let's supply that at station 1400. It'll go in as a waste site. I'm going to allow it to just put any old material there that's extra. So Q1, infinite volume, and we'll let this do its thing here. And we'll see that it's going to add a waste pit icon there, and we should be able to get rid of our little warning. So no warning. Or, what's that saying? It may just be that, oh, just telling us that we've changed it slightly. So everything is good. We've got this balancing now. Let's take it a step further, and we're on benign terrain here. It doesn't make sense to haul all that material that we're slowly accumulating along the length of our road to a spoil site. So rather than hauling it, let's just allow it to be disappeared, disposed of adjacent to our road. And for that, we'll go into right-click vertical options in our Project Explorer panel. We'll go into constraints. We'll click sidecast. And here we'll tell the software that I want it to allow it to dispose of up to, I'll just arbitrarily choose a reasonable number, 5 cubic meters per linear meter of road. So I'll hit add edit. So that's going to be active. And now instead of hauling all that material to that spoil site, we're going to see, we have to recalculate for that to show. We're going to see a sidecast hatch show up here. So there we can see that in these sections it makes sense to just disappear that material as we encounter it. Just a quick side note, and movement isn't our main focus of things here, but just to avoid any confusion, or reduce any confusion anyway. Our mass haul diagram, in this case, is showing us a surplus. So right now that mass haul diagram isn't taking into account that we are side casting material. If we go into our mass haul options and tell it to use these opti-haul volumes, which is this graphic that I'm using here and what the software is using to actually figure out what materials should go where, and as a part of the costing side of things, which we'll get into in a moment. We can change this to report the volumes that are being tracked in our opti-haul. So the opti-haul is still going to show you things like material movement direction, where you've got multiple material being moved in different directions at the same location. But if you want to just have a quick view of whether things are balancing and whatnot, the opti-haul will, well, the mass haul with opti-haul will at least show you that you're actually side casting material there. Not show that attribute to a surplus. All right, so let's continue along here. All right, so next we have template-specific material requirements. And this isn't necessarily just template-specific material requirements. But I mentioned when we were talking about quality parameters, if we wanted just one specific material assigned, well, we could uncheck replaceable. That makes sense given the UI that we just looked at. But if we want to account for other materials in our road prism, we absolutely can. By default, we don't. But if we want to account for, say, your surfacing material or other materials for different uses, could be armoring, etc., we can tell it, well, I want surface volume 1 to be associated with bill material X. And if we want it to just be X, not replaceable based off of the quality of X, we'll uncheck that replaceable box. So once again, we will look at things here and continue along with that same example. So I'm going to just add in an extra ground type here. So it's going to be something unique that I don't already have. I can go through and apply all the different parameters that I think are appropriate for it. Change my costs to be what I'd like. And this new material that I've created can only come from one location. So I'm going to add a pit for this one material. So let's say that this gets added in at station 400. It's a borrow source. It's my well-graded base. And we'll hit OK. Actually, I'm not going to even let that calculate. I'll just hit cancel. So if I want to account for my surfacing here, and if I want that to be that well-graded base material, I can. And my OptiHaul can track that volume for me. We can track the material for it. And we can do that by jumping in here and saying, well, surface volume 1 is well-graded base. We'll hit OK. We'll hit OK. And it's going to take a moment to figure things out, but it will account for the fact that that material has to come from the location that we've allocated for it and include all those material movement distances with it as well. So there we are. And if you guys were paying attention at all to what we have over here, which is our next topic, costs, we can see by accounting for this expensive material that we previously weren't, our cost jumped up. Doesn't make the project any more expensive than it would have been. It's just the fact that we're keeping track of that, which is valuable. So let's take a moment to chat about material costs. So we introduced where those live in the ground types library. Our materials have associated handling costs with them. So each material can have a unique cost to excavate, unique cost to turn it into an embankment, so that place, shape, compact aspect of the construction process. And our movement costs are going to be shared amongst those materials. So we can really quickly mess around with those unit values and see how it affects our design. And if we account for that detail, well, it's certainly going to help us make better decisions. And we can see here that Project Explorer panel is where we're going to report our costs. And this is the foundation for that OptiHaul movement, so figuring out what material should go where and come from where. It's also the foundation of our vertical optimization. So if we want to let the software figure out where our vertical alignment should be to minimize our costs, well, this is the groundwork for that. We need the cost relationship defined. And then if we want to look at things like what pit should I open up, whether I should sidecast or haul to a spoil site, etc., all of this is related to those costs. So the software is going to look for the cheapest solution given the parameters you put in. So I'll once again do a quick show here. So far in this example, I've got a total cost of $418,000. And I'm going to go with a quick change here. I'm not going to change everything. I just want to show that if we change these numbers, it obviously affects what we have going on here. So let's just say this is going to cost $30 instead of 12. We'll recost. And we've changed our cut cost, so that's going to change our total cut cost and our total cost as a result. And ta-da, our cost has jumped up here. So that is, we kind of combined all of our um, quality parameters, specific material requirements, costing, and pits, spoil sites, and sidecast into the same example that we built on. Now let's jump back. And subhorizon depth and subsurfaces. So in this example that I had previously clicked along, I've just assigned different materials along different station ranges. So I haven't accounted for any material depth whatsoever. Of course, that's kind of a simplistic way to look at it. There's often times where you'll have one material over another material. So we have two options for how we can assign those depths of materials. The first is just to assign a fixed depth, in which case if you're assigning a bedrock layer, that bedrock layer is going to follow your top host surface. The other option is, well, we could assign it based off of its own independent surface. So for that, and as we can see in that image to the right there, the material can be independent, and in this case we can see as it goes further to the right that bedrock layer is getting deeper. So let's take a quick look at how that appears in the software. And yeah. All right, so same example, and it's one of those things that I will circle back here shortly, and rather than focusing on just one thing, we'll actually apply these to what we started with. Let's see it all at once. So here, if I zoom out, I can see I've got no other layers showing up here. If I'll just go somewhere where it might be interesting. So I've got this assigned here. If I go into my assign by range, subhorizons, and I am in this range here. So I'm just going to do it to this one rather than everything. But I could say, well, we've got solid rock and it's at a depth of 1 meter. We could say okay, and we can click add edit. So I've got hard pan over solid rock. And there we are. We can see that other horizon, and we can see here where our cut slope, we've got our cut slope set to auto, so it's looking at what material we're going through here, taking the cut slope associated with that, and then what material it's going through here and taking the cut slope associated with that. Now let's get a little fancier here. And if we want a surface that's independent, we can go into options. We can go to terrain surfaces. I'll click add, and I'm going to add a subsurface layer. And I've got this depth to bedrock terrain file set. So what that does is it gives me the ability to, rather than assigning that fixed depth, I can pull in my depth associated with that. So once this is done reading in that extra terrain file that we've added, we're going to assign where it's read in at. So here, instead of using that center line depth of 1, I'm going to tell it to use a surface. I'm going to click surface 1. So we've got that. I need to click add edit, so it says sub 1. And here we can see that we've got, well, we've got shallow bedrock here, a little deeper at the top, and then down below we've got a different depth being fixed just because we've got that independent surface functionality there for us. So that is in a nutshell, everything. I guess the last step is just to take a quick run through um, rather than just incrementally showing how all these different things affect the project individually. You don't have to think about it in that sense. It's really easy to just follow this material's here, this material's here. I need to strip it, just assigning all those parameters at once and updating your design early in the process, and then you can make better decisions and be comfortable with the volumes that you're reporting and whatnot. So I'm going to exit out of this. I believe I've got this one on the go that we had started with. So back to square one in the same example, and we'll assign those parameters, look at everything that we have going on, and in this case, it's one of those things that the order doesn't really matter too much as long as you account for it, and it's certainly you don't want to finalize your design without accounting for it and then add it in later because you'll have to update everything. So just to start, I'm going to switch my screen layout over. Again, order for this doesn't really matter, but I am going to talk through what I'm doing. So in my ground types, I could read in my own ground type table if I had something saved that I wanted to use. If I had something unique here that I wanted to have as my default going forward, I could hit save and save it over normal.gdx, and that would be what appears when I open the software. Now, if I wanted to start from scratch and add materials in, I could. So I'm going to I know I'm going to need it, so I'm going to add that well-graded material. I'm going to set my parameters to match what I'd like. 1.5 to 1, 1.5 to 1, that's great. I want it to be a material that doesn't expand or contract, so 1 to 1. I'll set my costs. I'll go with $20 here. If it was a real project that I wanted to represent my own costs, I'd go through and make sure all the materials that I want to use reflect the unit rates that I'm going to have applied. So these are our default values. Encourage everyone to change them to what best represents their local costs or local materials. So maybe that your hard pan is different than what I'm considering hard pan, in which case set it to be whatever you'd like for those geotechnical parameters, cost parameters, or quality factors. So we've got our ground types defined with what we'd like to pull from. I'm not going to tell it to recost or recalculate just because I'm going to continue to click around here. On this project, I want to have that 20 centimeter stripping depth applied throughout. I'm going to go in here, site prep. We'll set that, slope stake base. We'll click add edit. Again, I'm not going to worry about recalculating. When I'm assigning my depths for my materials here, I'm going to use that subsurface layer that I have. So let's pull this in. So my corridor surface, subsurface, depth to bedrock. And again, I'm not going to worry too much about that. And now I'm going to assign all those things that I'd like to assign. So we'll go through our subhorizons. Now if this was a real project, I'd maybe have my GPS points in the background showing me what I expect to be there, or if it was early in the design phase, I'd make a best guess based off the landforms. So I'm going to assign my best guess. So subhorizons. Now I'm going to tell it to be hard pan over solid rock throughout. And since I have that subsurface layer assigned, I'm going to just bring that in so the depth's going to change accordingly. I'll click that. And here on this project, most of my top layer is going to be what I'm considering hard pan. Now, for this, I'm going to split out that one section where I expect there to be gravel. So I'll say from station 1125 to 1195. Oops. 1125 to 1195. And I made a common mistake there. So I've got that. I want to make sure I make that different. So gravel. Otherwise, I'm just splitting it up with itself and it goes back in. So that's great. Now, pits. I know I want to have some pits along here, and I happen to remember the numbers from before. So I want a pit at station 400. This is going to be my borrow pit with that well-graded base material. I've got an infinite capacity. I'll leave that as is. If I expect that's going to cost money to open that pit up, though, for site prep or maybe moving equipment in for it, I can add an extra cost on there. I can also add in an extra dead haul distance. So if my pit was, say, a kilometer away from that location, I could add in a 1 kilometer haul distance to be included in there. We're going to add in another pit at station 1140. That is my borrow source for just my run-of-the-mill gravel that I'm going to use for that fill. And I'm going to add in a spoil site at station 1400. So this is my waste site. It can be any old material. So we've got that. Now, if I happen to know what I'm dealing with and happen to know that I want to have that specific fill through that specific range, well, there's no need to jump out every time. I can go in here and say, well, I want to have Q3 or better through from 1435 to 1510. It's replaceable quality based. We've got that assigned here. And I'll hit OK, and I'll recost it just for the sake of recosting it. But I'm not quite done. If you remember in that previous example, I want to allow side casting to dispose of my material, and I'm going to do that over here in the Project Explorer vertical settings.
And while that calculates, just a reminder, if you'd like to ask us a question on the webinar, we're going to move over to that next. You can enter your questions by expanding your GoToWebinar panel and just type in the questions. You do stay anonymous.
All right, and yeah, that last step of the side cast, I'm going to leave this as just showing me my standard mass haul for now. But I'll take note that my total cost right now is $300,000. We'll go in here, we'll allow that side cast up to 5 cubic meters per linear meter. We need to recalculate, so recost. And this won't update because it's just going to show my mass haul. But we'll see that the total cost should be reduced a bit by what we're saving for hauling that spoiled material. Oh, and I forgot one more thing, but oh, and I guess it didn't actually save me very much at all. But let's take a look at what's going on in the solve. It might just be that it's a really small number. So we want to see our opti-haul. And it's not taking. Yeah, and I guess it's all getting used. Yeah, so I guess, yeah, it's all getting used. I guess my what I ended up assigning ended up with a deficit rather than a surplus. The last thing that I want to account for there is I didn't tell it to use that well-graded base in my materials. So I'll go up here, I'll set that here, and I'll say, well, that surface layer 1 has to be my well-graded base. I don't want it to be replaceable. And with that, that pit at station 400 should be opened here now. And with that, that'll do its thing. And yeah, I guess here that would be the place where I'm probably going to start refining my alignment, so I'm not actually having to borrow as much material and taking into account all these interactions that I'm going to have with the surrounding terrain. So that is our 1 hour of material types, and yeah, we'll open it up for some questions.
Yeah, we've got a bunch of questions here. Let's tackle definitely at least a few of them. I know we're going to go a couple minutes over. And if you have a question, feel free to type it into the question section. We do follow up with every single question, even if we don't cover you in the actual live webinar. Let's start with the first one. Can the stripped material be defined as the volume between two surfaces?
I'm not 100% sure I understand the question, so I will take my best stab at it. Now, the stripped assignment here, to report that as overburden removal, we've got that assigned here. So that is what's going to be tracked as my strip volume when I go into my data table and I tell it to include strip. So this is the overburden removal. Now, that's great if that's the way you'd like to account for it. If you have something from your template that you would like to account for that as a different material, you can, but it won't be that same attribute. So it could be maybe a sub X from your template. And let's see. So it could be something like that, in which case that's being tracked as cut surface volume 5. So it's not going to be that same parameter that you have in there, but you could set surface volume 5 to be reported as a strip volume or sub X volume when you have it assigned in the in your data table for reporting. So hopefully that covers the question.
Yeah, and if that question asker wants to clarify it, if we didn't hit what you're asking for, yeah, please put it in the question section and we'll get back to you. The next question, are there definitions for the ground types in our manual? For example, when we receive a geotechnical report or boreholes, they use different examples such as silty clay or gravelly clay for the definitions of the in-situ soil.
I like that question because it the answer is no. But the reason the answer is no is these default materials that we have assigned are kind of meant to be just a nudge in the right direction. So some of these, well, solid rock, for example, you could have solid rock that is, say, a schist material, or you could have like a granodiorite material, and the two are going to behave differently. One you'll be able to cut at one angle, the other you'll be able to cut at another angle, depending on a bunch of other things. But they're also going to expand and have different expansion factors. So what I'm getting at here is we aren't claiming that these are going to be right in every situation. What we encourage our users to do is to modify these and build them out to reflect the conditions that they commonly encounter, or it could be project specific. If it's something that you commonly encounter, well then a great strategy is to save that out as your normal, so you don't always have to update those values to reflect what you're constantly working with. And if it's project specific, well, let's just open something in here. So I've got this. Now I've got the same material names here, but the reason I have that name something differently is I've got different excavation costs. So if you want to jump from different GDX files from project to project, by all means save them as different things. If you're constantly working with the same thing over and over again, saving them as the normal .gdx will have that default when you open the software.
Awesome question. Okay, let's do, just looking at the time, let's do two more. Our next question, how do you calculate the cut and fill ratios?
The expansion and compaction factors, I would say that the, well, if you have really good as-built survey information and keep track of what goes where, you can derive them yourselves. But the whole field of ground types, it really is a field in and of itself. So if it's something that you're not sure about, I think the err on the side of caution is to just reach out to a geoscientist or geotechnical engineer that works in your field and your area, and they may happen to have some kind of rule of thumb values that you can use, because it will change depending on the industry that you're working in. So if you're building roads that there's not much compaction versus if you're building airport runways where there's lots of compaction, you might have the same material, but it's going to pack down to a different value. So yeah.
Okay, last question and then we'll wrap it up. Can different haul costs be assigned for different materials?
So your hauls are assigned globally. Now you can have different, yeah, that's the short of it. Now you can customize them to be whatever you'd like. Yeah, but you should be able to account for that discrepancy or any variation in between there, assuming your actual haul. So let's just pop this open here. So our haul has two parts of it. It has the actual hauling part and the loading part. So if you're putting material in a truck, that truck can probably go the same speed, whether it's rock or overburden in the bed of it. So your hauling cost should be unique. For the loading, any difference in the loading cost, that's assuming the primary excavation has already taken place. So it's not that the material comes right out of the ground and gets loaded, it's that there's a primary excavation of it. So if I'm digging out my solid rock, well, I first have to do that primary excavation before that material is loaded at that typical rate that we use or you assign. So not directly, but the structure of it should give you the flexibility to account for that difference.
Okay. So I just wanted to say thank you to Matt. A huge amount of detail. We've actually never done a webinar on this particular topic. So hopefully your key takeaway is that ground types definitely matter. They had a huge amount of realism to your project, and hopefully he's shown you, a few different examples of how they're implemented and worked with, including the cut and fill slopes, the expansion and shrinkage factors, how you can leverage stripping, that idea of material quality as it pertains to your in situ and original ground, as well as to the materials that are applied back into your fill. and then leveraging subsurfaces. So a huge amount of content, and we really hope that you enjoyed it. This video, as always, will be posted up onto our YouTube channel. And if you're watching this in the future off of YouTube, feel free to give it a like. We like likes. They're always fun. Or write a question in the comment section below. We're happy to answer it. And to those of you in the live part, have an awesome rest of your day, and we look forward to seeing you again soon in another webinar.
Perfect. Thanks, everybody.